This one's new to me. What's a lake house? Let's talk a little bit about lake house architectures, how it manages to compare against data lakes and data warehouses, and learn a little bit more about what it means for AI and how to connect this all to our customers. Ori Rafael is the CEO and co-founder of Upsolver and joins me today on this bonus episode of The Business of Tech. Thread has declared death to the ticket. Did you know tickets date back to the 1800s? And customers hate tickets. Thread uses an approach for connecting, communicating, and ultimately collaborating. Thread allows people to come together around a topic. They can discuss and make decisions. They can share and invite the right people. The future of service is collaborative. Supercharge your service experience by seamlessly integrating AI and automation to meet your customers where they are, in Teams, Slack, and desktops, not in tickets. With instant updates to and from ConnectWise, Autotask, and Halo PSA, keep all communication in one place, where it should be, with people. Decrease time to resolution 30% with chat-based support by visiting getthread.com/MSP Radio to declare death to the ticket. Well, Ori, thanks for joining me today.
Thank you very much. I'm excited to be here.
Well, I'm going to dive right in because you started out with a concept that I'm not familiar with, and this is the idea of the lake house concept. This is, we often hear about, data warehouses, but you're introducing the idea of the lake house. Talk to me what that is and how it fits into the overall theme of data management.
Sure. So the short answer is that the lake house is a type of data warehouse architecture. That's the one-liner that explains it. And if you look at what were the previous architectures, so you had the enterprise data warehouse, that the on-prem data warehouse that people were using, the Oracles, the Terraform, the Teradatas of the world. Then came the cloud, and now you just did the same thing you did on-premise, but did it on a cloud-managed instance, and that would be Redshift. But you still had a lot of the challenges that DBAs had. For example, you could run out of space in your database because it was using local disk. Then came the next generation, which was the decoupled data warehouse. So the storage and compute were separated. You paid for them separately. Data warehouses became easier to use and more scalable comparing to what they were before. A lot of talk about elasticity came with the version of decoupled data warehouse. But still, there was a problem because the decoupling was inside the data warehouse vendor. So that problem, like if you were a DBA and I was a DBA, you always hated being locked to Oracle. You hated it because it cost you a lot of money, and it hated you because you needed to use Oracle for the things it wasn't really built for. I think today the modern way that you see this is that you have a company or a customer saying, hey, I want to do BI with Snowflake and I want to do AI with Databricks, for example. So I want to use different platform, but once I lock my data into a specific format, into a specific provider, I can't really do that. And then came the idea of the lakehouse. With lakehouse, you, Mr. Mrs. Customer, are in charge of building and maintaining your data layer. That means not just your files, your files and your metadata. So basically, you create tables, and then you use your data warehouse more as pure compute. It only does queries. It does read-only queries. It's mostly read-only queries. And the idea of this is that you can use any number of query engine or warehouses on top of the same data that you as the customer are sharing. It's stored in your account, and you can share that across multiple engines, but you manage the security for that layer. Now, the concept of the lakehouse was introduced a few years ago. I can't say that I invented it. I think the entire market is adopting lakehouses. The latest survey I've seen is that 70% of the enterprises are going to run at least 50% of their analytics on a lakehouse within the next 3 years. That's a kind of a massive shift. There was a lot of, people call this the open table format wars. What will be the format in which you're going to store this data? There were 3 formats that came into light: UDI, Delta Lake, and Iceberg. And going into the opinion rounds for a second, Iceberg seems to be like the clear winner. There are certain things that caused the market to believe that Iceberg is going to be the format. And right now, every warehouse on earth that I know is going to support Apache Iceberg as the format. So you can write an Apache Iceberg-based lakehouse, and you can read that data from pretty much every warehouse that you want. So that's the idea of the lakehouse.
Okay, so help me understand, like, what do you think consider like the real competitive advantage here of why the lakehouse architecture is going to be the big change in data management?
I think that there are two very strong reasons. The first is cost reduction. And cost reduction can happen both in the sense that you're not using the engine that you don't want for a use case. You're not locked in. You have more negotiation power. But in addition to that, and I come from the ETL space, from data movement space. And when you move data into the warehouse, you have to communicate with the warehouse. So you have to have a warehouse clusters up and running in order to do your ingestion. That's going to cost you a lot of money. It's expensive query compute used for ETL. When I write Iceberg, I don't need to communicate with a specific warehouse. I can just write Iceberg. So all of that budget that you're currently paying to whatever warehouse vendor for ingesting data into it, in some cases also transforming data on top of it, all of that budget just goes away. From my customer base, it's in many cases more than 50% of your warehouse budget that would go away. So there is a substantial cost reduction. And this is why the early adopters that we are seeing are customers that have a high scale of data because they are really feeling that cost reduction benefit. So that would be benefit number one. And benefit number two is the ability to use multiple engines. So many enterprises you're going to talk to are going to come with the agenda. I don't want to marry a specific warehouse vendor. I want to enable the AI revolution by creating an open data layer using a lakehouse. So that would be the business strategy reason, and there would be the cost reduction reason, and both of them together are very, very powerful.
And one of the things you've been really focused on is the optimizing storage to improve speed and efficiency around data queries. Tell me a little bit more about what you've been doing there to make the difference and why it matters.
Yes, I can do that. So imagine that you want to move from a warehouse to a lakehouse. So you're doing a POC and you built your own lakehouse layer, you built your own storage, and then you go and you run your queries, and then you find out that all your queries are 2 times slower. So there is a lot of objection from within your organization to actually move to the lakehouse because you're hurting user experience. In addition, there is quite a lot of variation, right? What's going to be your storage efficiency? And you can find yourself paying a lot more for storage, in some cases more than double the storage budget, just because you moved from a lakehouse into a warehouse. The reason these things happen is because you need to manage the file system. You own the data layer, so you need to manage the file system. So that's an additional burden on you as the customer, and that burden is very familiar. Every company that has ever done a data lake knows that burden, and in many cases, that's the reason company says, hey, I have a data swamp. It's too complicated. I can't really get any value out of that. So we are what you would call an iceberg manager. We manage your file system layer, making sure you're going to get a query performance that's similar to what you get in the warehouse. And we're going to make sure your storage efficiency is going to be very good. And maybe the last thing that we are adding, we're also making your warehouse real-time compatible. So we are allowing you to write updates and deletes into the warehouse at a high velocity, which is something that would otherwise would be impossible on top of open table formats. If you combine real-time and deletes and updates together, those things don't mix together very well, but we manage the file system in a way that you are actually able to do it. The most common example for that is CDC, change data capture, the concept of copying data from a transactional database into your analytic database. Whenever you want to do this use case, you need to apply updates and delete to your analytical warehouse. That's going to be a challenge, and like doing it once a day diminishes a lot of the business value of connecting that data into your warehouse. So those are the main 3 things that we had. We had performance, we had storage efficiency, we had the ability to do read time on your warehouse. That would be with Upsolver iceberg management capabilities. We also have ingestion capabilities, but right now we're focusing more on the lakehouse, and now we are kind of finishing that piece, solving the customer that piece that will really make your lakehouse perform as a warehouse.
Interesting. So one of the other things Upsolver has done is focus on the idea of making data engineering skills more optional, particularly as they relate to data lakes. Tell me a little bit about how you've transformed that and what you view are the important skills then that a data engineering team should be thinking about.
Well, data engineering, there is quite a lot of variety, but let's try to very roughly separate the data engineering team into the traditional warehouse people, the SQL people of the world, and you have the Spark people of the world. Those are two different profiles. Regardless if you come from group A or from group B, we can accelerate and improve the efficiency of your warehouse. It's either way going to be hard work. The difference is that the Spark people would be able to try to craft some kind of DIY solution. I have asked some of the companies I've talked to and eventually did that themselves, what do they think it will take? And they said, we think it's a 6 to 9 months journey to really learn how to do it well, monitor, go to production. So we're going to save you that 6 to 9 month journey. If you're coming from the SQL space, it's not very likely that you're actually going to do it well. You could buy it from a different vendor, maybe. But if I compare DIY and what we do, then we're just going to save you in the 6 to 9 months, and we're going to get better performance. Right now, Upsolver has the best performance that I know in market for managing a lakehouse. And we benchmarked it and released the benchmark. So this is based on results that you can find on the website.
So as platforms like yours become more and more part of the way solutions are rolled out from a data perspective, how do you see the role of data engineers evolving over the next few years?
They're not going to go anywhere. The data engineers are definitely here to stay. And for example, I can tell you that my perception of a data engineer, and I was a DBA and a data engineer, and I know the job well. I think that the data engineer would like to be a platform manager and not a developer for R&D team. So if the R&D team needs to come to the DBA or to the data engineer and ask them to build, to write code to support the workload, then basically everything is being funneled through data engineering. So you're creating this bottleneck, and that's exactly the reason people didn't like data lakes, for example. This is why we have agendas in the world like data mesh today, talking about freeing up all the people that are domain experts, not necessarily data engineers, to build their own workload. So I think platforms like Upsolver and in generally the Lakehouse are helping data engineers be more independent from software engineers. They're going to give them the platform. They're going to support it. They're going to monitor it. They're going to make sure the security is maintained. They're going to make sure users' data privacy is maintained. So data engineers are the chaperones, but they don't need to be the developers. And I think we are seeing that trend very strongly in the market over the last few years. So it's not something that you would tell an enterprise and they will say, no, we've never heard of it. Everyone has heard of it.
So you're a guy who spends a lot of time thinking about this and has thought a lot about these various roles. What are the next big trends you think in sort of data integration and database management that business owners should be thinking about and preparing for?
Well, I'm going to repeat the same one again, because if you're going to look at practically every article I'm seeing covering the warehouse, open table format is going to be number one. So what does it mean for you as a manager in an enterprise? You need to understand how a lakehouse looks like. It's no longer one box for a warehouse. So you took the database, you ripped it apart. So now you have a catalog. Now you have an open table format you're using. Maybe an iceberg manager, so a file system manager like Upsolver. So you have 3 pieces to what used to be, actually 4 pieces with the query in it. So you have 4 pieces of what used to be just 1 piece. You need to understand what catalog would I want to work with. Do I want to buy it from a warehouse company? Do I want to buy it from the cloud provider? So all of that education is something that a manager in an enterprise working with data need to do. I'd say that the second thing they need to do, and talking from a data engineering perspective, is how to support AI in a better way. So open table formats are not enough. Probably you want to be able to bring additional tools around AI. Vector database is a great example, a new category of database that didn't exist in the past, but is very relevant today in the Gen AI future. A lot of people are talking about simplifying data modeling, although I haven't seen that yet. I've only seen UI to support the process, but I haven't seen AI to replace data modeling because it's a job that requires a lot of accuracy and is very sensitive for hallucinations. But I think we're going to see more co-pilot type of behavior there. And I think that the last would be governance. Now, also related to the lakehouse, how are you going to manage your governance across multiple engines? The number of data engines you're going to use is going to increase. How is governance going to be maintained? That's a question that the market is also, there is still a lot of innovation that happened in the market this year. So you should kind of catch up, understand where things are going, and kind of choose what you want to do.
Interesting, because that's exactly where my last sort of question goes. You brought up AI, and we'd managed to get most of the interview without bringing it up. But that's sort of the last question. I think a lot right now about governance, and I think there's a lot, particularly as we get into the smaller end of the market, there's a lot of organizations that have not done a good job of thinking about their data governance, particularly before they can even take advantage of artificial intelligence. What are the kind of guidance and direction that you, as somebody who thinks about data a lot, give to organizations as they put together their data governance frameworks?
Well, first of all, there is your policies. There is the answer for AI, and there is the answer for data in general. Let's say you used to work with Snowflake, and your access control policies were in Snowflake. But now if you're using two other engines for AI, those policies will not translate. So kind of the open data layer is composed of files, metadata, and governance and access control. That piece of access control is getting solved right now in the market. So Snowflake released an open source called Polaris as the data catalog, and AWS supports it. Other companies, other cloud providers support it. Databricks released their catalog, Unity, into open source. Amazon is doing work around that. You kind of need to choose where is your catalog going to be, because now you're going to actually have the option of having policies that will translate across multiple engines. That would be piece number one, who actually has access to the data. With AI, there are additional risks, and to them, maybe I don't know how to tell you the full story, but how are you preventing data, like your sensitive data, to be part of a model that might expose your organization inadvertently? That's not my area of expertise. That's something that you should definitely think about, but not my area of expertise.
Well, a perfect place to end, because that is exactly what I want our listeners to focus on, is that's the area that listeners should fill in for their customers. Ori Rafael is the CEO and co-founder of Upsolver, a pioneering company in the lakehouse data management space. With nearly 20 years of experience, Ori is focused on revolutionizing how businesses handle complex data to drive efficiency and cost savings. Ori, thanks for joining me today.
Thank you very much.
Looking to reach an audience of thousands of MSPs and IT service providers? Put your ad right here on the Business of Tech and be on the show that 64% of MSPs report having listened to. A recurring top 50 tech news podcast. There are affordable options for you to reach our audience, and we can support any budget. Podcast listeners are more engaged, have a higher level of brand retention, and are more willing to listen to ads here than any other avenues. Want to know more? There's information at mspradio.com/engage, including a button to book a time to talk. I'm looking forward to that discussion. The Business of Tech is written and produced by me, Dave Sobel, under ethics guidelines posted at businessof.tech. If you like the content, please make sure to hit that like button and follow or subscribe. It's free and easy, and the best way to support the show and help us grow. You can also check out our Patreon, where you can join the Business of Tech community at patreon.com/MSPradio, or buy our Why Do We Care merch at businessof.tech. Finally, if you're interested in advertising on the show, visit mspradio.com/engage. Once again, thanks for listening to me, and I will talk to you again on our next episode of The Business of Tech.
Part of the MSP Radio Network.